Hello, everyone. My name is Brian Page, and I'm doing this presentation as a part of a class. So, I'm taking a medical physiology class at the University of New England. So, as part of our course in medical physiology, we had to pick a topic on the digestive system and present and record ourselves. So, bear with me, it's my first time using the screencast app. It's my first time presenting and posting on YouTube, so we'll see how things go. We'll try to have fun. Hopefully, I don't bore you too much with the nitty gritty, but I actually think this is a very interesting topic. So, I chose to present on the short and the long reflexes of the enteric nervous system. The reason why I chose this is I'm actually in practice. I'm a clinical psychologist, so I currently work for the Department of Corrections in Illinois, and I'm going back to school to get my master's degree in clinical psychopharmacology. So my ultimate goal is to be able to prescribe medications. So in addition to providing psychotherapy for the patients that I work with, I could also prescribe medication. So, as part of the prerequisites for this endeavor, I had to take several courses to include medical physiology. So, I chose the brain and I chose the nervous system because it's something that I deal with on a day to day basis. So, let's get started. Let's dig into this presentation that I put together here. All right, so I thought these were interesting pictures, kind of funny and entertaining. It just really shows that there's a big connection between the brain and the gut, the digestive system and the brain. As a psychologist, I know this because often I have people tell me that they have a gut feeling about something. Often people say to trust your gut. And I think that's very important because we actually have this whole system. It's part of the autonomic nervous system within your gut that kind of triggers those feelings. Sometimes people get butterflies in their stomach. You see in this depiction, there's a big um, connection here between the brain and gut, and in turn, the gut and the brain. So this is kind of funny, gutsy move for a brain. The enteric nervous system is sometimes called the second brain. Hold on one second, I gotta let my dogs in. Now that I let my dogs in, they were barking in the background. Probably heard it. We'll get going here. So move on to the next slide, if I could. Okay, so the enteric nervous system is one of the main divisions of the autonomic nervous system. Essentially, its job as the second brain is it controls the motor movements of the GI system or the peristaltic contraction. It also controls secretion of enzymes. One of the key features of the enteric nervous system is it has the ability to act independently by itself. So it doesn't have to be influenced by the other aspects of the nervous system. But it can. So it can be influenced by something called the parasympathetic and the sympathetic nervous system. In particular, the enteric nervous system is innervated, or there's nerves intertwined by the vagus nerve. So the vagus nerve is cranial nerve number 10. And they call it the vagus nerve because it's a wandering nerve, kind of related to, I think, Vegas, Las Vegas, the wanderer. It goes from the brain all the way through the stomach. So definitely that could influence the enteric nervous system. However, research shows that even with the vagus nerve severed, that the enteric nervous system could work. So it can act independently. So there are several characteristics or similarities between the enteric nervous system and the central nervous system, or the brain and the spinal cord. First of all, according to Silverthorne, there's some intrinsic neurons as far as neurons that are solely encompassed within the enteric nervous system. Secondly, the enteric nervous system involves neurotransmitters and neuromodulators, just like the central nervous system does. Actually, a fun fact is the most serotonin is actually encompassed within the stomach, within the enteric nervous system. So we as mental health professionals, we often prescribe something called SSRIs, or selective serotonin reuptake inhibitors. And a big side effect of SSRIs are GI distress and GI discomfort. Well, one of the main reasons why is what SSRIs do in a nutshell is increase the amount of serotonin so the person feels better in the brain. But it not only increases the serotonin in the brain, it also increases the serotonin within the gut, which creates the GI distress. There's also glial support cells within the enteric nervous system, just like within the central nervous system. So those astrocytes and those oligodendrocytes, there's those support cells. There's a diffusion barrier. So in the brain, it's the blood-brain barrier. There's a similar system within the enteric nervous system. And there's also an integrating system, or where all the information is integrated and moved together and processed. Let's just say that. So, what are the short and the long reflexes? So, these short reflexes are actually reflexes that are completely encompassed within the enteric nervous system. So, there's no outside influence at all. The sympathetic and the parasympathetic nervous system not involved at all. So this acts independently. So the enteric nervous system plexus are in the gut wall, and those are often called the little brain. There's something called submucosal plexus that contains the sensory neurons, and it receives signals from the lumen of the gut when there's a distension, an expansion of the gut. And it also signals the control of GI enzyme secretion. So there's also something called the myenteric plexus, which actually controls the motility, or the ability to move food throughout the GI system. So the plexus in this impacts the muscularis externa of the lumen, which increases motility and helps. So this is a diagram taken from the Silverthorne text on medical physiology. I think it's a pretty good depiction of both short and long reflexes. So just kind of in summary, we'll talk about the short reflexes since that's what we just talked about. So it says here, short reflexes originate in the enteric nervous system and are carried out entirely within the gut wall, and that's right here, as you can see, the enteric nervous system, or the little brain. So the short reflexes are depicted by the red arrow. So just in summary, that there's a distension of the gut, or the presence of food, or the osmolarity changes, the acid changes, which in turn triggers sensory neurons within the gut wall, which goes into interneurons, which trigger the enteric neurons to impact the smooth muscle, which changes the motility, as we said, increases enzyme secretion, etc. So this is all encompassed within the enteric nervous system, and there's no outside influence, like we said, from the central nervous system, from the brain, the spinal cord, the sympathetic and the parasympathetic nervous system. On the contrary, there's something called long reflexes of the enteric nervous system. So these digestive reflexes are integrated within the central nervous system. So this is kind of resembles a classic neural reflex in that a stimulus is transmitted along a sensory neuron to the brain or spinal cord. The stimulus is integrated within the CNS and is acted upon. the smooth muscle and glands of the GI tract are under the autonomic control of the sympathetic and the parasympathetic nervous system. In particular, the parasympathetic nervous system via the vagus nerve um, enhances the function of the GI system. So the parasympathetic nervous system is often referred to the rest and digest system. It helps us relax and kind of digest our food. On the other hand, when the sympathetic nervous system is activated, which is that fight or flight system, our GI functioning is inhibited. There are a few types of long reflexes within the uh, these are also called cephalic reflexes. There's emotional reflexes. So these are, I kind of compare it to Pavlov's dog, where there's an association between an external event and a physiological reaction. So in Pavlov's classical conditioning, there's a connection between food and salvation. That's the same thing with this. When somebody gets butterflies in their stomach, traveler's constipation, there's an emotional reflex there. And there's also a feed forward reflex, which we'll talk about in the next slide, but that is just it's an anticipatory reaction to food being digested, etc. So this talks about the long or cephalic reflexes and over here. So the person sees food, tastes food or smells food, and in turn the brain via the medulla oblongata sends information via the vagus nerve to enteric reflex, which in turn impacts target cells to increase secretion and motility. This also depicts the short reflexes, in which the distension of the GI gut impacts sensory input, which in turn increases secretion and motility. So kind of the same thing. This is the same diagram, but I just want to kind of quickly go through the long reflexes of the enteric nervous system. Again, they're integrated within the CNS. Some long reflexes originate outside the GI tract, but others are originating in the GI tract. So there's this feed forward mechanism in which a sight or smell of food impacts the sensory neurons, which in turn triggers enteric neurons to change the motility and change the enzyme secretion. So there's an outside influence. It's not just within the enteric nervous system. The brain is triggering this cue to help you digest. I'm reminded of the ballpark when I go to the White Sox game. You just smell the food and the Polish sausages and the hot dogs cooking, and you're kind of just anticipating that food. So I could relate to that, and hopefully I'll be out there going to a game soon here. So, in summary, the enteric nervous system is a division of the autonomic nervous system that could act independently or be influenced by both the parasympathetic and the sympathetic nervous system. Short reflexes are completely encompassed within this enteric nervous system. On the other hand, long reflexes have influence outside from the central nervous system. Um, Examples of long reflexes are the emotional reflexes, in addition to the feed forward or the anticipatory reflexes of the system. The enteric nervous system is sometimes referred to as the second brain, just as due to its ability to almost act independently and almost have its own reactions. I know sometimes I just get that gut feeling sitting with somebody. When I'm anxious and nervous, I kind of feel it in my stomach. Maybe during this presentation, my enteric nervous system was activated due to nerves, but I appreciate you listening to this presentation. Hopefully, it was helpful. I don't know who's actually going to view this outside of my teacher, but if you do, give me a big thumbs up. hopefully this presentation helps you in the future. And